Okay, I guess we started. So welcome to the fifth and the last online academic seminar of this semester. And thank you all for your interest in participation in the seminar today and throughout the semester as well. Today we are hosting Dr. Zerrin Doğança Küçük. She's an assistant professor in the education department at Maynooth University in Ireland. The title of her talk is Metacognition in Action as a Possible Explanation for Stock Flow Failure. There will be a question and answer part after her talk. So the floor is yours, Dr. Doğança Küçük.
Hi everyone, it's very exciting to be there. I see some familiar names and I miss all of these people actually. And actually this is my second academic seminar. I remember I presented in 2012. The moderator was Professor Güzber Yıldıran at that time, and she was the dean also. And she wants us to present our research in the faculty as research assistants. So this is my second time, and still it is still exciting. And today, firstly, I should introduce myself because I see some students and some other people. So I was graduated in primary mathematics and science education in Boğaziçi University. I was one of the first graduates actually from this program. And then after studying as a mathematics teacher for 1 year, then I returned to Boğaziçi University and started my master degree in Environmental Sciences Institute. But still, I was working as a research assistant in the education faculty and then continue my PhD in the same institute. And then I started working in the Bahçeşehir University with teachers this time in both STEM Center. And for the last 3 years, I've been working in the education department in Ireland and in Maynooth University in Ireland, and still working on science education and system dynamic and environmental education. These are my research interests. Today, maybe I should start to share my screen. And today I want to present you our recent publication with Gürsu Aşık. He is my colleague and friend from the faculty and also from Bahçeşehir University. We had different research interests. He is working on metacognition, and at that time he was working with Emine Hoca. And my interest was about system thinking. So in this study, we combine our research interest. Hopefully, Gürsu will join us at some point because I'm not an expert in metacognition in front of Emine Hoca and Engin, but still I can respond some of the questions. So this was a study that I think metacognition was not well known in the system dynamics field. So we tried to propose a possible solution in this study, and we look for the effects of metacognitive skills when solving system tasks. So the outline of my presentation is like, I will talk a little bit about the nature of problems that we have in daily life at global level, and stock flow structures in these problems. System thinking, I will introduce a little bit about system thinking and the stock flow failures identified in the literature, and introduce metacognition and related to stock flow failures. and then introduce the methodology, findings, and discussion of our research. So most of our problems in daily life and the problems at global level, they are highly dynamic, nested, interrelated, and complex. On my right, you can see a system dynamic model, and it looks really nested and complex. Actually, the number of stocks in the model is related to the complexity of the problem. The problem they studied in this research was about the effect of lockdowns in the number of contacts. And they worked on different scenarios of lockdowns, and try to understand the relationship. So you can see there are lots of variables affecting the stocks, and there are a few flows also represented in the diagram. And if you are interested, the scenario with one clear lockdown and what they called is like smart lockdown with people continuing their activities but minimizing their contacts works best among those four scenarios. So to introduce a little bit about the system terminology, stocks, we can assume that there are accumulations, and they are represented as rectangles in the stock flow diagram. And flows are related to rate of change, like inflows and outflows affecting the stock. So when we think about our daily problems, even like balancing our diet habits and exercise, it's challenging for most of the people, because there's not a linear relationship. Like when you eat, you don't digest directly. So there's those kind of delays. Another example could be like to decide on carbon dioxide emissions, to control carbon dioxide level in the atmosphere. It is challenging, and still we are facing this problem. So most of these complexity comes from this structure of those problems. So I want to define a system dynamic field from Yaman Barla's definition. He defines that system dynamic addresses dynamic, long-term, complex problems. So this is the definition of the field, and they work on system thinking, which involves identifying parts of a system, seeing their interrelationships, representing and assessing the dynamic structure of a system. So this system thinking definition comes from Sturman, who is a pioneer in the field, and also Sweeney, his student and also an educator. In the literature, system literature, there are some definitions for stock flow failures. They identify and classify stock flow failures. Correlation heuristic is like the tendency to associate, like to relate stocks and flows, like to expect a linear relationship between stocks and flows. So another wording for that is linear illusion, which I really like also. When you control some kind of some level of carbon dioxide concentration in the atmosphere, you shouldn't expect a direct response with the global temperature change. So there is not a linear relationship between these. Another difficulty to conceptualize stock flow structure is related to stocks structure. Like they have inertia, they accumulate over a long period of time, and they don't respond. They don't give sudden response. this is another thing, like when there's the carbon dioxide accumulation in the atmosphere, it doesn't give direct or sudden responses to the to what people, politicians, decisions about controlling the emissions. So it is hard to give short-term decisions. And I want to introduce a few studies related to stock flow failures, because in system dynamics, researchers try to change the structure of the tasks and look for the results. If it makes sense, people can do it better. So there are various studies on this, but there is this consistency that there is a low level of correct responses to stock flow tests. Even when they did these studies with university students from well-known universities like Berkeley, Stanford, still the correct response rate is very low. And there were some manipulations in those tasks, and they looked for the results, like they changed the structure of the representation of the tasks, like graphs, wording, word problems, or a difficulty level of the tasks, context of the task. Sometimes they give incentives, some extra feedback, or they introduce a priming introductory test to support their understanding of the task. Most of these alterations didn't work, actually. People still perform poorly in those tasks. But in some of the recent studies, some priming activities seem to work, like maybe it's because of the context or the unfamiliarity of the tasks can be some of the reasons. Sorry, suddenly. Suddenly it's the end. Here. So then when we look at this literature, and we really like those cognitive processes in those studies, but when we read about this study, Cronin's study, like they say that system failures are mainly based on people's decision-making processes and using inappropriate heuristics. When we see this statement, we were very excited, and maybe it was the time to try something with metacognition. And what if when we try something related to metacognitive activities and do the same stock flow task with our samples and look for their metacognitive activities? Maybe it could be it would give us some insight about these low responses. So this study was a motivation for us, because the previous studies mostly concentrated on cognitive contextual structures, and we want to examine in depth the problem-solving behaviors and teaching strategies of people. So I should also define metacognition. One's knowledge concerning one's cognitive processes and products or anything related to them. It is a well-known definition of it. It involves active monitoring and regulation. Active monitoring is related to one's knowledge about one's own cognition, and regulation is the use of this knowledge during the ongoing cognitive processes. So in this study, we concentrate on metacognitive skills, which are the procedural knowledge for regulation and monitoring of one's learning processes. So our research questions, what are the differences of metacognitive skills of individuals who solved the task correctly and who didn't. And our second question was related to the participants who solved the task at their second trial. After we give the feedback, it was incorrect, and we let them to solve it once more. So we want to examine their thinking processes, how they regulate their thinking process to achieve in the task. So in our study, there were 40 junior and senior students from mathematics education program in Boğaziçi University, and these are the information about the participants. And we can assume that these students had a adequate mathematical background, considering the mathematics courses they took in the college. So for the procedure, each participant had a maximum of 30 minutes, and they were given two well-known stock flow tests, and they solved it. And while they were solving, we encouraged them to talk about how they are solving the problem, what they are thinking at that moment. So we can say that it's the single subject concurrent think aloud protocol, and we record their performance. And the only time we talk to the participants when to remind them, if they stop talking, to remind them, please continue talking. And another one is like for their first trial, we just say correct or incorrect, and if they are incorrect in their response, they retry with the task. I think the tests are important, especially for maybe the mathematics educators. So this is one of the tasks, and it is the challenging one actually, department store task. And to introduce the task, maybe the first two questions related to task. Maybe I should give you some time to read the task, but like there is a store and there are people leaving and entering to the store. And this is the graph for 30 minutes time. And there are four questions, four sub-questions. The first two questions actually related to reading the graph, but the third and fourth are challenging. So third one is like, which minute were the most people in the store? And fourth one is like, which minute were the fewest people in the store? So in most of the cases, people think instantly, but they should think in terms of all the people in the previous minutes and like the accumulation in the store. So it is a little bit challenging. And this is the second one. I think this was more familiar for the students because there is this, it's like the acceleration velocity kind of problem. There's this bathtub, and at the end there's some water, like 100 liters of water at the start, and there is this graph of inflows, water coming in and water going out from the bathtub, and they are expected to complete the graph for quantity of bathtub stock per minute. So this is the second task. So they were supposed to complete these tasks in 30 minutes, and 30 minutes, according to our pilot study, it was more than enough to solve the two tasks. And this is the checklist assessment tool we used during the problem solving sessions. There are three stages: orientation, text performance, and evaluation. Orientation is like an introduction, a preparation for the task, like reading, paraphrasing, understanding the task. And the test performance is related to like planning. So they are solving the task at that moment, making calculations, maybe taking some notes. And at the end, they are supposed to evaluate their overall problem-solving process, check their answer. These are the stages. According to our pilot study with two other students, we couldn't observe the skills that are shown with X's. Maybe it's because of the structure of the tasks, like especially in the first task, there was no estimation. And it was not just for the pilot study. For the other 40 students, we couldn't observe these skills. We couldn't report about these skills in the study. And if you could remember the structure of the first task, department task, we don't expect an estimation. They are expected some direct responses, like they select it from the graph and say directly which minute it is. So not so much estimation is going on. So we didn't observe any for this task. So for the findings, the descriptive findings were very consistent with the literature. Although we have very good students, mathematics students in the department, still they had difficulty to solve these tasks, especially department store tasks. At their first attempt, 6 students could solve that. With the feedback, 8 more students solved the task. And for the backup, half of the students could solve it at their first trial and 7 more in their second trial. I think this is the most important finding, most important quantitative finding maybe. We try to understand how they perform in those metacognitive skills. So we assign 0 for no performance at all for those skills, 1 for partial performance, and 2 for full performance for the skills. So it's interesting, especially the department store test. When we see reading, 90% of the participants perform it fully. And unfortunately, when you look at the 2 column here, the numbers go down as we go through the skills. So it looks like when they concentrate on the task performance, the skills, they perform less of these skills. This is one of the important things. When we look at the BEDTAP task, when we look at the number 2 column, they read not very good as the department test, but there are better percentages in other tasks. Maybe it is because it was a more familiar task. Now I want to give you some quotations from the participants and try to give you the picture about these tasks, especially the department store task. So these are, I want you to remind you that these are mathematics students, so they also have some school placement experience, and some of them already had some teaching experience in university and preparation courses. So they have these kind of experiences, but still they some of them, they didn't read the task fully. So it was an important case because they were reading aloud during the problem solving session. But it's interesting. The ones who read clearly, they read it once more time. Sometimes they concentrate on some of the phrases and repeat it a few times. It was interesting to observe. And for example, one participant didn't read the task. They concentrate only on the graph, and then they ask the question whether the sub-question A and C are similar. At that point, maybe I should remind you A and C, because this is a common mistake actually. So during which minute did the most people enter the store? So instant, they're expecting an instant response. And number 3, during which minute were the most number of people in the store? So it asks for accumulation and all the number of people at the store. And the ones who didn't read it carefully, they were confused with these sub-questions and, oh, what is the difference for these questions? Was a question from at least one of the participants. And one successful person, actually, this participant solved this task in his first trial. So probably he or she was one of the 6 people who could solve it at their first trial. So the participant said that I didn't understand the question completely. I would like to read it again. So spend some time paraphrasing some of the words constantly while reading it. So again, for the orientation part, selecting relevant information was one of the metacognitive skills. So we identify this quotation from one of the participants. Like, the highest number of people in the store is at the 4th minute because it is the minute that the highest number of people entering takes place. I think this is a very good reflection. Like they are thinking instantly. They have the sense that the flow and the stock somehow they are much more related than there is this relationship. So it is an important reflection, I guess. And there are some responses that include nearly approximately words, although on the graph it is very clear, the minutes are identified very clearly. So these responses, we assume that, like, even though if the number is correct, but if there is nearly and approximately wording, we assume it's for that, like, partial correct answer, because it's not nearly or approximately, it's the exact minute at that time. Another quotation, the number of people entering and leaving are given, but the number of people in the store is not given. Oh, and this participant was confused, like there should be more information given. But this person tried to understand without the giving information how could he or she solve the problem. So and he said, like, I couldn't solve the problem because there is missing information. And yes, one important thing, we identify a magical phrase in the task, like if the people say, if the people identify over 30 minutes period in the task, and some of them, like, they rephrase it a few times, and during the task performance, they repeat this phrase a few times more. So whenever they say it, they solve it. It was an interesting thing, like because they feel the sense of accumulation with this phrase. So it was an interesting thing. to observe. And we identify we classify the plans of people, like we call it level zero plan for our unorganized plans, or plans with just one flow, or for level 1 plans that focus on 2 flows. So, like, for example, the moment when the difference is the highest and the moment when the difference is lowest, like they identify at least 2 flows. But there's also this stock when they identify the stock also and the accumulation over time. If we assume it is level 2 plan. So we have some phrases for level 2 plans, like I have to shape the area below the graph. Up to here, it is increasing, then decreasing. So and I put the graph here to remind you. So yeah, actually this 13-minute is the critical point here. And this is the break point, and the participants show the breaking point, which is like 30 minutes on the graph. And it changes after the 13 minutes. The behavior of the stock changes after 13 minutes. So when the people identify the break point 13 minutes, they are more likely to solve the problem, or like at least comprehend it better than the others. So realizing the break point is also an important moment for us. For the evaluation, I also included some quotations from the participants, and I want to read it because it somehow reflects high-level monitoring. The highest number of people is at 13th minute, because after 13th minute, number of people leaving is higher and the number of people in the store is decreasing. I consider whether there are people before this minute, and then pointing to the first minute at that time, the first area indicates an increase, while the second area indicates a decrease. The second area is bigger, so it means there are already people inside. Then it is the 13th minute for question D. So it is a very good explanation, and you can identify the break point 30 minutes accumulation. So it was a good quotation. And if you could remember, for evaluation part, there were 2 metacognitive skills: monitoring and checking the answer. So from one of the participants said that there is no need to evaluate deeply. The total number of people is the highest when the number of people leave the store is least. So instant thinking in an instant manner. This person is very confident with his solution, and denies checking the response. It was also very interesting. So we didn't observe lots of we observed a few students, participants check the answer. Some of them were very confident and some of them were confused, especially at the department store task. I just include the qualitative findings for the department store task, which was the more challenging task, and hopefully we can discuss it further in the Q&A part. So just to remind you that our motivation was this phrase: we know little about the mental procedures people use in solving these problems and why. This was identified by Gonzalez and Wong. They were also cognitive scientists, and so they mostly concentrate on cognitive processes. And this was a motivation for us to include metacognition. Overall, we can see that most of the participants read the given task, do the calculations correctly, but they perform poorly at the task performance and monitoring part of the tasks. even though they are mathematics students, yeah, it was an intentional selection. So we just wonder whether these students can perform these skills. Maybe it's because of the pressure of the experiment, or because the unfamiliarity of the task. It was the case for our study. Lack of selecting relevant information and we identify some keywords like over 30 minutes of time, break point, and for the bathtub it was over. Now I couldn't remember, but we also identify some keywords for the bathtub task, and I think it's important to identify these keywords to design some further studies. Maybe these keywords will help people to solve these tasks better. So it was an important thing. And they were, these participants had some experience, real experience about teaching, about mathematics problem solving. So most of them, they were confident. Some of them were confident, even though we give that the feedback that their response was wrong. They still like, no, I think it's okay. It's okay. Some of them were confused, but most of them were okay with their answers. They seem confident, and it was an interesting observation. And some unsuccessful participants were stuck even at the lower metacognitive processes, like even in the orientation part, and we see the percentages there. So it was also interesting. So it gives us some light, like, yes, maybe it is because of those metacognitive skills. Maybe they perform it, they could solve the test. So there is some light about this. And for our conclusions, like I think checking the response, checking the answer was the most prominent one in the study. So it has some implication maybe for the mathematics education, like maybe we should concentrate on these metacognitive skills and encourage them to perform these in their teaching also. We should familiarize these system tests. Maybe we could include these tasks in university level in mathematics education courses, and let them experiment these tasks with the students at the schools. It could be interesting because these are very most of these tasks are the problems that we encounter in daily life. So they are related to our daily life skills. So it is contextual. So I think it could be useful. So in this way, they can be familiarized with those tasks. These identification of keywords and probings, I think they make some difference in their understanding and solving the tasks. So there could be lots of combination of these tasks with different variations, and you can implement these tasks and do some further research and look for the differences among the people who could solve and who could not solve, or, and also compare it with the literature. So there is this kind of excitement about these, I can say. So these are, although they seem very small right now, these are my references. There are very good references from metacognition, I guess, and also some studies from system dynamics literature. So thanks so much for your time. I want to stop sharing and to see you, and maybe you may have some questions. Thanks so much for and clapping also.
Thank you so much, Dr. Doğança Küçük, for this inspiring and wonderful presentation. Actually, I have some ideas for my research as well. Right now, we can take the questions from our participants. Please feel free to unmute yourself and ask the questions, or you can just raise your hand as well.
Oh, Gürsi is here also. So,
yeah.
Gürsi, please, if I miss anything, can you say anything about the research? Because he is the leading author in the study, so he may have some things to share with us. I'm forcing him to do so. And also, Engin said that you want to keep the references for yourself. Yeah, it looks so from the slide. I'm sorry for that.
I think it's a very nice work. I can't find any question to ask or anything to say. So.
Maybe from the metacognition side, if I miss anything, please add.
Actually, the important parts for me, from my point of view, from metacognition, since it is difficult to talk in front of Engin Hoca about metacognition, but we try to catch the moments that how problem solvers think in such a difficult and challenging question. So it is also motivating for us, trying to catch the moments, what they say, how they think, and the parts that they have problems, they have difficulties. So I hope we accomplished to catch some of those parts in this study.
And this article was published in System Dynamics Review. So it was very challenging, the publication process. There were lots of reviews going on. It was very challenging because they had the reviewers had very different perspective. They at least two of them we can identify were not from education, from system dynamics part. So they have very different perspective. They ask very direct questions, and we had difficulty with Gürsi to respond them in the exact manner. So it was a very interesting experience for us, and we are very proud that it is published there. At the start, Yaman Barlas was the editor of the journal, and then he was replaced with Marcus. Do you remember the final editor?
I don't remember.
Emre approved, so that should be correct. I saw it.
Yeah. So it is interesting, and during that time we feel more respectful towards Yaman Hoca, and interestingly, he was facing some issues in Boğaziçi University at that time, and he was one of the he is the editor of this very well-known, highly ranked journal. So it was a very unpleasant experience for us from this perspective. Yes, it was very interesting. Yeah. Any questions about the research? We can respond. Yes, thanks. Accepted by Marcus. Still couldn't read. And I know that Gaye is doing a research about system dynamics with Darüşşafaka schools, and Emre is supporting them. He always supports these system dynamic events in education, so it's very nice to see people. And I think Büşra is doing a master thesis on system dynamics, also system thinking.
Zerrin,
very nice.
Emin Hoca has a question for you.
Yes.
I actually want to make a couple of comments naturally. I want to congratulate you. That's the wonderful. It's wonderful to hear you talk about this. I'm very proud that it has been published. So I'm so excited. But I have a couple of comments. I actually, Zerrin, you talked about impulsive answers to of the students at some point in trying to solve the problems. They tend to answer without thinking much, and you emphasize those points. Actually, I am interested in those because the ability to stop those impulses and start thinking maybe and using one's metacognitive skills is an important skill in itself. And I think it is called inhibition, the suppressing that instinct to answer immediately. You mentioned that a couple of times the students' impulsive answers. So were you referring to that? I wonder. Were you interested in how those inhibition skills of some of the successful students stop them from answering impulsively? I wonder. But on the other hand, I have a comment. In a study we did with Fatma Acar, we wanted to see the relative, should I say, I shouldn't say effect, but relative role of inhibition and metacognition of on solving such problems. We call them irregular, what was the name? We call them questions that are not familiar to the students, such questions that are not familiar to the students. And what we found was the role of metacognition is much more
interesting
in being much more influential. Metacognition is much more influential in achievement in solving such problems. So I have an answer.
Interesting.
But
please.
Since you mentioned those impulsive answers, I thought it might be interesting at one point to study where the students give those impulsive answers and which students repress the urge to answer impulsively and use their metacognitive skills. So
yes.
These were my thoughts as I listened.
Yes, it's interesting because there were just 6 students who could solve the task at their first try, and 1 or 2 of them, they solve it, like they read it carefully, and somehow we lost like what are the skills they are using, because suddenly they give the answer. And we said, stop, please tell us, how did you solve these problems? Because there were some fast things going on and we couldn't catch these at the moment. And some of them tried to explain it and explain it very well, and one couldn't explain it but solve it with the right answer, and he was very confident with the response. So I think this was the thing, like they solve it, but I think this is the limitation because we skip those things. Some people didn't speak well or explain the process as well, but it was the thing. Kirsten, please, like, do you want to add something here? Because it is metacognition. I do not want to say something wrong.
Actually, it's not metacognition, but the others, inhibition.
Inhibition, yes.
But it is very difficult to assess inhibition. We used in our studies Stroop task and maybe you know about this. You show, for example, you write green in blue letters, and so it is confusing for people. And some people who have high inhibitory skills can say the right thing, but it is very difficult to assess. So it is very difficult to detect. But on the other hand, I think from what you tell us, this may also be an important aspect. But on the other hand, from our study, I can say that metacognition has a more influential role. So you were right in studying metacognition.
Hocam, actually, for example, for estimating the possible answer section as a metacognitive task, we also recorded how students think, how students solve, recorded the process of problem solving, but we were not able to observe estimation for those problems. They are like an implicit action in their mind, so we eliminate those steps in our evaluation. We couldn't catch those points, and as an impulsive answer, as Zerrin said, some of them just directly give the right answer, so we couldn't catch anything. But for some of them, especially for the second research question, when we say them, your answer is wrong, some of them did not accept their wrongness. So they said, no, it is true. Rather than in evaluation and looking at the problem, they believe themselves. They don't need to read anything more, but they are not aware of. They were not aware of what they did. So it was interesting for us to catch the second step when we told them the answer is wrong. So it was interesting also for us.
But it is a metacognitive experience, feeling of knowing, which has a mediating power, as you know.
Yes, actually, it was one of our suggestions at the end of the article. We should observe those participants, such kind of participants, while solving system dynamic tests. We need to observe their metacognitive experiences, metacognitive feelings of knowing, feeling of understanding, but not in this study. In the further studies, we need to do it. I don't know, maybe we can do another research for searching feeling of knowing, feeling of difficulty estimations of participants.
Engin?
Yeah, I was thinking of how you could possibly take that further, that strand of research further. I had some ideas as well. One is the calibration literature around this might be interesting. It's seen as a manifestation of monitoring, metacognitive monitoring, the monitoring accuracy. There are a variety of terminologies being used, but that might be interesting to link it strongly with that strand of research. But also listening to what Emine Hoca suggests as well, I think the experiences are worth studying, if possible, maybe providing them with the tools, the terminology to help you explore in more detail. You could look for ways. It directly reminded me or made me think about the Kahnemanian way of looking at processing this thinking fast and slow, the system one thinking and system two thinking, how people make such decisions, which kind of system to operate in this kind of task. This might be about familiarity, it might have things to do with inhibitory control. Often people, especially with young kids, they take inhibitory control as somehow as a sister construct with metacognition. But that might be an interesting context to build some further work onto, especially the Kahneman framework might be interesting about the decisions people make while working on such problems?
Actually, I don't know what Kahneman structure framework is, but I can check.
Well, thanks for the suggestion.
It's basically about in some instances it's system 1 and system 2 thinking. One is more instinctive and fast and easy to progress, whereas the other one is you're a lot more wary of where you might go, and so you're taking your steps rather slow. You're probably taking that into consideration because you think that it might be something unfamiliar. There might be obstacles can take place for a variety of purposes.
Okay. And might be one important experience for us. Actually, in the publication process, it was really difficult to explain what metacognition means to the referees. Since many of them, referees working in system dynamic discipline, most of them are have engineering background, so they look for explicit findings, not explicit, very clear findings about those processes, strict discriminations between the processes, but it is really difficult to make an explanation about what metacognition means, how it works in cognitive thinking. So we need to write long sentences to the referees about this is a kind of metacognition. So making a collaboration with those students is also, I think, important for us to make familiar them to metacognition. I hope. But we can do some further research.
Thank you. In terms of familiarity, actually, what Engin mentioned, he mentioned about familiarity for metacognition, maybe, but I have a question about it, actually. So did the students have any training about systems thinking prior to or anything?
No. We just introduced these tasks, nothing more.
Okay. If there's
so it is a question.
Yeah, so I hope we will find a solution for that. And then I have a solution. And is there any other question? Because I have another question, but if there's another question, I can let someone else ask the question first. Because we have an engineer here. Engineer, so if there is an engineer perspective, if there's a question from engineer perspective, okay, I guess not. My second question, and then I guess we can end if there's another question. So you said the department task was more difficult than the bathtub task. So I wondered how or why you selected the difficult task first, or implementing the difficult task first, and then more easier one. Because you implemented the department task first, and then bathtub task. So I wondered, like, why and how you selected these tasks, like the order of these tasks.
Actually, because they have totally 30 minutes, so they will spend these 30 minutes according to what they want. Like and generally they spend more time in the department task, and sometimes they solve it quickly for the bathtub test. So it was the case, but maybe there could be some difference, like they can get some confidence since they were able to solve the bathtub task, and then they can solve the department task. But we didn't think so much about this, like but just think in the pilot study we observed that they spent more time in the department task, so it will be more efficient for them. That was the intention.
Okay, no, that makes sense. I was just wondering if there is a reason behind why you selected that one first, but I understand. Thank you. Any other question? Yes, Emre.
Well, actually, not a question, but maybe an observation. In these tests, these are actually tests for measuring the stock and flow behaviors, but the system dynamics or general systems thinking defines itself from a thing having a feedback approach, or defines itself with the feedbacks. So in these tests, there are no feedbacks actually.
Yes,
it's quite a linear, astonishingly simple tests actually, but I want to link this to the pedagogical side of the situation, because there is an argument to use first, which one to use, start with the causal loop diagrams or the stock flow diagrams. So this research, I think, strongly supports the view that one should start with the stock flows, then introduce the feedback afterwards. Even with this simple stock flow structures, humans, Homo sapiens, struggles means that introducing feedback doesn't help, or just
will be more challenging.
Much more challenging. Yes, thank you.
To remind for the other people, feedback is the link between the flow and the stock. It's not the feedback in education perspective. So and if you could remember the system model at the first slide about lockdowns, there are lots of those arrows which really the problems are they are connected, nested. So even it is very challenging. So that's why we have these problems continuously and cannot solve as humanity, because we cannot understand the structure. It looks so, it is linear. There are just two flows and one stock, and we cannot solve it. So yes, that's that looks so. Thanks so much, Emre.
You're welcome.
Emine Hocam?
Yes.
So after this explanation, so maybe we can treat your problems as the non-routine problems that we work on. So you have actually given two non-routine problems and investigated the problem solving on non-routine rather than actual system dynamics problems. But it may be a first step in teaching the systems approach.
Yes.
So it's a preliminary approach to teaching system dynamics to problem solvers. Clarify my sorry.
Actually, Gürsi defined them as non-routine problems in the article also. So it was confirmed. Good.
You should be proud of yourself now.
Yes. Yeah, Gürsi should.
Hocam, Emine Hocam, I think especially the first problem, the living a store problem, entering a living a store problem, it looks like an easy problem. And when we look at the structure of the problem with easy words, with easy, clear questions, and I feel that while the problem solver tries to solve it, he or she may feel this is an easy question. Looks like a routine problem at first sight. but it is not a routine problem. It's a non-routine problem. So this part is also challenging for the students, I think, especially for the first problem, department store task problem. Of course, non-routine, but as a at the first sight, it looks like routine easy problem, I think.
Okay, I think that this was really fruitful discussion, actually, both the presentation and afterwards discussion. If there is no other question, I guess we can end the session. Let me ask you one last time if there's any question.
Thanks so much for your time, for your interest to our study.
Yes, thank you, Dr. Doğança Küçük, and thank you all for joining us for this session. This was the last seminar of this semester, and we will be looking forward to seeing you all next semester with a great series of presentation as well. So have a nice break, I guess.
Thank you very much.
Thank you.
Thank you.
Bye-bye.